I want to treat this video as, us just going over our homework in class, that type of activity we would sometimes do. So last week, for the first time, I had you do a homework assignment over Google on Google Forms. On Google Forms. It was due last Friday. The bulk majority of you have that completed. It should be in the grade book. If you turn it in late, it might not be at this point, but anyway, it soon will be. And I just kind of want to go over those answers, and then you guys can figure out why you missed what you missed. So number one, man, I hope you can see that. It looks a little blurry close to me. It says an experiment is done rolling a six-sided die. Each time the die is rolled is called a or an, and your choices were trial, outcome, sample space, or event. Well, every time you perform an experiment is called a trial. The result of the trial is called the outcome. The sample space would be every possible outcome, and the event is what you would find the probability of. Like the probability of rolling a 3 would be the event would be rolling a 3. So every time we do that, it's called a trial. What we get is the outcome. So the most common missed answer was outcome. Number 2, it says, which is the best and mathematically correct way to write the sample space for rolling a six-sided die? I'm going to attempt to move this over just a little bit. Let's see what happens. Okay. So remember, when you write a sample space is a set, so it has to have those squiggle brackets. And if that's too small a C, it's 1, 2, 3, 4, 5, 6. Okay, that's what most people who miss this put, but it's not mathematically correct because in order to show that it's a set, you have to put those brackets. Number 3, when rolling a six-sided die, what is the probability of rolling a 4? Well, there's only one 4 on a six-sided die, so your probability would be 1 out of 6. Okay. Now, everybody who missed this either put 4 out of 6, or they put 2/3, which is just the reduced version of 4 out of 6. Hopefully that doesn't keep doing that. So you want to put the desired outcome . That won't keep doing it. So the number of desired outcomes is what goes in the numerator. Well, if you look at the sample space, which we just said was 1, 2, 3, 4, 5, and 6, there's only one of those, so the probability is 1 out of 6, not 4 out of 6. There aren't 4 4s, there's just the 1 right there. All right, on number 4, when rolling a six-sided die, what's the probability of a 4 or a 5? Well, these can't be done at the same time, all right, so they're mutually exclusive, which means you would just take the probability of 4 plus the probability of 5. Probability of 4 is 1 out of 6 plus 1 out of 6. That's 2 out of 6, which reduces to 1/3. All right, or when you see or in probability, you add. Now, if it could happen at the same time, you subtract where it can, but those can't happen at the same time. All right, number 5, when rolling a 6-sided die, what's the probability of 2 or an even number? Well, if you look at the sample space, 1, 2, 3, 4, 5, 6, there is 2, and then the even numbers are 2, 4, and 6. Well, that one's double checked, but it's 1, 2, 3, 3 out of 6, which reduces to 1/2. Okay, now if we were going to do that the long way, we would say the probability of even plus, the probability of 2 plus the probability of even minus the probability of 2 and even. That's 1 out of 6 plus 3 out of 6 minus 1 out of 6. There's only 1 2, so the probability is 1 out of 6. There are 3 even, so the probability is 3 out of 6. And there's one of them that is both 2 and even, so you subtract it. And you can see 1 6 and negative 1 6. We're left with 3 6, which again is 1/2. All right, number 6. I think we switched over to the spin wheel. It says using the spinner above, what's the probability of landing on blue? Well, only 1, 2, 3, 4 people missed this, so it's hardly worth going over. But there are 8 slices, 3 of them are blue. The desired outcome is blue. That's 3 out of 8. So we have a probability of 3/8. Number 7. What's the probability of a spinner landing on purple or yellow? Again, or should tell you to add. So we want the probability of purple plus the probability of yellow. They can't happen at the same time, so we don't have to subtract anything. 2 out of 8 are purple. 2 out of 8 are yellow. 2 8s plus 2 8s is 4 8s, which is 1/2. All right, on number 8. What's the probability of the spinner landing on blue or odd? Now, it can happen at the same time. That's both blue and odd. So these are not mutually exclusive. So we need to subtract where it does happen at the same time. So it's going to be the probability of blue plus the probability of odd minus the probability of blue and odd. The probability of blue, where there's 1, 2, 3 of those, so that's 3/8. The probability of odd, there's 1, 2, 3, 4 of those, so that's 4/8. And then minus the probability that it's blue and odd, there's only 1 of those, so you have to subtract that one. 3 and 4 make 7, minus 1 is 6/8, which reduces to 3/4. So the most common missed answer was 7/8. You weren't subtracting where it happened at the same time. If it can happen at the same time, it's not mutually exclusive, and you have to subtract where it happens at the same time. Number 9, what's the probability of the spinner landing on green? There's no green wedges up there. It can't happen. So that probability is 0. What's the probability that the spinner lands on even or prime? Okay, now, this again is not mutually exclusive. So we have to subtract where it does happen at the same time. 2 is both even and prime, so it can happen at the same time. So probability of even plus the probability of prime minus the probability of even. I have to use a lowercase p, I don't have enough room. Even and prime. So even, there's 4 out of 8. Prime, there's 1, 1, 2, 3, 4 of those as well, minus the one that is both prime and even. 4 and 4 make 8, minus 1 is 7. So we get 7/8. Alright, that's it for today. Hopefully you checked over your work. You'll have a new assignment tomorrow. Have a good day.